Another term that is critical in replacement analysis after marginal cost is minimum cost life, MCL. It is a well-established term in the field of replacement analysis, and it is the life, it is the age, it is the number of years that makes keeping the car, the machine, the equipment, the asset the most economic. It means that if you keep, for example, if MCL for an asset is 8, it means that your cost for keeping this car, this machine, this asset for 8 years cannot be less in comparison to other years. For example, we are sure when they are telling us minimum cost life for an asset is 8 years, the cost for 7 years is higher. The cost for 9 years is higher. The cost for 6 years is higher. Why we are sure? Because we have been told that the minimum cost life is 8 years. So that's the practical definition of that. Now let's check more polished definitions we have for minimum cost life. The service life of an asset, that's exactly the age of the lifespan of that asset, that produces the lowest possible annualized cost, EUAC, for that asset. When a car is, because when you are comparing the cost of a car, when you want to compare the cost of a car over 7 years and 8 years, you know that you cannot use present worth. You know that you cannot use future worth. And now see how the basics you learned before come to help you here. And everything makes sense. Because now you may ask why it is referring to EUAC for calculating the minimum cost life. You may say why we are even calculating EUAC for seeing which one is the minimum cost life. You can track down all the answers to all the lectures, to all the practices, to everything you did before in this course. So you want to compare 7 or 8 years. So you cannot use PW, you cannot use FW, since the number of years are different. You need to go for annualized cost. If you remember, when we discussed this approach of analysis, we said that you can compare a project of 12 years with a project of 6 years because you have already annualized everything. So your analysis would be independent of the year themselves since you have annualized everything over years. Okay, so we got that. Why we need to calculate EUAC. Okay, after that, we go and calculate EUAC for 6, 7, 8, 9, 10, and we go for the minimum one. Now when you read this again, it's gonna make sense better to you. The service life of an asset that produces the lowest possible annualized cost for the asset. Everything now makes sense. Another definition, the specific number of years, okay? You should ideally keep the asset to minimize EUAC. The same as the previous one, just different wording. If you keep it 1 year more, it will increase it. If you keep it 1 year less, you will increase it. Why? Now in the third bullet you see it. If you keep it shorter than 8 years, it means that you are paying too much per year to recover the capital you invested at the beginning. Because when you are keeping it for 7 years, it means that the initial investment you have made need to recover itself over 7 years instead of 8 years. If you are trying to sell it after 6 years, it means that the initial investment needs to recover itself over 6 years. That means that recovery amount per year gets higher and higher. Okay, you may say, what about we consider longer years, 9, 10. In that situation, the recovery per year of the initial investment would be smaller and smaller. Yes, that's correct. But the problem is that you will have higher maintenance and operating costs that increases the annual cost. So that's the reason. There's one optimal point, minimum cost life. Here is an example. If you keep the asset for 1 year, EUAC would be 12,000. Now you ask, how we are supposed to calculate EUAC? You already know it. Just the same way we discussed all the examples before regarding calculation of EUAC, EUAB, EUAW. So you have in all of them an initial investment, you have salvage value, and you have maintenance. So if it is 1 year, these things goes on 1 year, 2 year here, and like that. You already know all the details. So that's the reason we are focusing and taking our time in explaining the concept. The smart and brilliant idea of making the most out of those tools we learned together. If you keep it for 2 years, it would be 9,500. Why? Because now it has 2 years to recover that initial investment. 3, 8,800. And 4, it starts to go up. Why it goes up? Maintenance, operating costs. But for sure, the recovery of the initial investment over 5 years would be easier than 2 year, 1 year. But here the problem is operating costs, maintenance. So 3 is the minimum cost life for this example. The map you see for replacement analysis is a very famous model. It's a textbook model. Is it something that any financial manager must follow, otherwise they get the wrong answer? Absolutely no. It is just a suggestion. Just consider it as a suggestion that repeats itself. It is really well established in the literature, and you can find it in almost every textbook. Because in terms of training, it's enlightening. But when it is in a real world that can be as diverse as infinite situation, based on the time, based on the company, based on the situation, based on the force, and many other factors, you as a critical thinker, you as an analytical thinker, financial manager, should come up with the best model and make the decision. But here, as a start point, to have some general structure that can help you understand the challenge better can be helpful. So let's check the model together. Defender and best challenger. It means that here we have had, for example, 5 challengers, and out of these 5 challengers, we pick the best one. Again, it's just a classic model. You may do it in another way. So, as I told you, marginal cost is very critical in replacement analysis. So you see also in this famous model, it plays an important role in a way that it splits the path of decision making based on availability of data on marginal cost. Okay, we are gonna follow all the routes that you see here in this map, in this flow chart. So here, defender marginal cost data available. So we have the data on the marginal cost of the data. We exactly know if we want to use our machine for 1 more year, how much it cost us. So here, another question it is asking us, is defender marginal cost increasing or not? Now we are here, correct? Is the defender marginal cost increasing or not? According to the definition now you have for marginal cost, you exactly know what it is talking about. Yes, it is increasing. So when it is increasing, it means that in 2 years the cost of keeping this much machine is higher than the cost of keeping in machine for next year, 3rd year. So here, what's the main point? It says that you don't need to calculate EUAC for the defender. Just go and check the annual cost for next year. Or in fact, easier, the cost of this machine for next year. Why we shouldn't go for the remaining lifetime? Because it is increasing and you have very insightful data that is marginal cost. You don't need to trouble yourself that much. Just go and see how much does it cost you if you want to keep it for 1 more year, and compare it with the challenger EUAC. If the marginal cost of your defender for the next year, and it is also annualized because it is just 1 year, is greater than EUAC of the challenger, go and do the replacement. Okay, what if the defender marginal cost is not increasing? It is now in a stable situation. Okay, in that situation, since it is not increasing, you need to calculate EUAC. And it makes sense. So you are going to calculate EUAC on the defender and compare it with EUAC of the challenger. If it is greater than the challenger EUAC, replace it. Otherwise, keep it.